binomial. Binomial again, or maybe for the first time if if this is the first time you've seen it or heard me talk about it, but there are 4 conditions for something to be a binomial. First condition, that there are 2 and exactly 2 possible outcomes. Then, so there's only and exactly 2 outcomes. P, the probability of success, stays the constant. So in every independent trial, let me add that, independence. Every trial must be independent of all previous trials. All right, remember, independent means the likelihood of one event does not or is not influenced by a previous event happening. Rolling a dice, roll a die, get a 2. That does not change the likelihood of the next thing coming up and being a 2 or not a 2 or something else. So P is the probability of success, and P needs to stay constant. So P is constant. And then finally, there are a finite set of trials. Finite trials. All right, so let's say we assume that our class does not have the ability to distinguish whether or not water is or is not tap water. All right, so if they cannot tell if water is tap water or is not tap water, let's say we're saying tap water is what my desired outcome is. Can you tell if something is tap water? And if you have no ability to discern whether or not you drink something and it's tap water or not tap water, then we're going to assume that you're just guessing. So the probability of successfully saying that something is tap water is 0.5. It's a 50-50 shot. All right, so Q is the likelihood that something is not P. All right, so Q is equal to 1 minus P. All right, so that's equal to, in this case, 0.5 minus 0.5, which is still just 0.5. All right, and let's say this year there are 12 students in class. We're going to find the probability that exactly 7 people correctly identify that the water that we have is tap water. All right, so we go up here and we say to ourselves, is this a binomial situation? Are all 4 conditions met? All right, so are there 2 outcomes? Yes, there's tap and bottled water. So there's only 2 exactly outcomes. So it's tap and not tap. Is the probability constant? Yes, 0.5 is P for all trials. And notice I'm writing all this down because I have to write it all down. You can't just say yes. Independent. Does one person's ability to discern tap water influence someone else's ability? The answer is no. It can't influence someone else because your taste buds are your taste buds. So you would have to say a longer sentence that I'm not going to write here, but basically saying one person is not influenced on whether or not they can identify tap water based on someone else's. All right, finite trials, we're going to do 12 trials because there are 12 people. All right, so then I go to the binomial formula, which is NCR times P to the R times Q to the N minus R. And then I substitute in values. All right, so this is going to be equal to 10 combination 7. All right, again, 10 is my N, that's how many total trials I have. And R is the number of successes I want. So successes are 7. Total number of trials, not 10, correct me on that, 12, because there are 12 people in class. Let's see if I can erase that real quickly here. All right, that's gone away. So I have 12 C7. All right. P is the probability of success, and I did the wrong thing again there too. I don't want equals. P times P, which is 0.5. And I want 7 of them to happen, 7 successes, so it's 0.5 to the 7th. Then I want times my probability of failure, which is also 0.5. How many failures do I want per se, I guess? That's 5, because 7 and 5 makes for all 12. So when we're doing this, we're recognizing that these 2 numbers have to add up to n. These 2 numbers have to add up to 1 as I'm working through this. And then, of course, I'm going to go to my graphing calculator, and I'm going to find in second vars, which is distributions, binom PDF. And then I'm going to fill in n. So I'm going to do 12, comma, 0.5, comma, and then how many successes? 7. NPR. All right. Fill that in. So again, second vars on your graphing calculator, which is binom PDF. Put in those numbers, fill that in, and then write that probability into your reflection response, along with an explanation of what it means in context. All right. So this is your basic ideas of a binomial. I'm going to add one more thing here. Let's clear. The binomial, we're again still talking only about a binomial. The average and the standard deviation. The average of a binomial of x is equal to n times p. So in the case of what we just did here, we had 12, comma, 0.5. So what this means is, on average, for every 12 people that are selected, on average over time, over doing this multiple times, each group of 12, I'm going to expect to see about 6 successes every time. All right, that is 6 people are able to identify that it's tap water. Now, if I ever get fewer, like a lot fewer, or more, or like a lot more, then maybe it makes me start to question whether or not that 0.5 is really true. All right, standard deviation is equal to the square root of n times p times q. So in this case, that would be I do 12 times a half square rooted. All right? So, and that would be my standard deviation of this binomial scenario. So that's the mean and standard deviation of a binomial. Again, you first have to show that the conditions for binomial are met before you can use either of these two formulas. All right, and later on we're going to find out that, oh gosh, you know, when n and p are both over 10, kind of like foreshadowing now for you, when n and p are greater than 10, we can actually use a normal curve. So then I know the mean and the standard deviation for a normal curve. Well, that's it for now. Binomial distribution, how to use it quick in context, as well as the mean and standard deviation. See you in class.